Sir, you can start the session. I will share my screen.
Okay, sir. Okay. Just wait. So, very good morning to all. It is my privilege to introduce our distinguished resource persons for today's session, Dr. S. Rajkumar. Dr. S. Rajkumar is a professor in the School of Computer Science and Engineering at Vellore Institute of Technology, DYPCET, Vellore, with more than 15 years of experience in teaching, research, and academic leadership. He has made significant contribution to the fields of computer vision, digital image processing, machine learning, and deep learning. He has published more than 85 research papers in reputed international journals and conferences and authored 4 books and holds the 3 Indian patents. He has successfully led and contributed to several prestigious research and consultancy projects under the DRDO, SPARC, UQuery, DHR-ICMR, Samsung R&D India, and Applet Limited. Dr. Rajkumar is the recipient of several prestigious awards, including the Outstanding Research Award from Vellore, the Best PhD Thesis Awards from the Computer Society of India, and multiple research awards for his outstanding academic contributions. He is a senior member of IEEE and a life member of CSN and ISTN, actively contributing to the research and innovation in emerging technologies. Today, Dr. Rajkumar will deliver an insightful session on generative AI. We are confident that his expertise and experience will provide valuable knowledge and practical insights to all the participants. On behalf of the Department of Computer Science and Engineering, DYPCET College of Engineering and Technology, Kolhapur, I extend a warm welcome to Dr. S. Rajkumar and thank him for graciously accepting our invitations. So, all dear participants, please join me in extending a warm virtual welcome to our esteemed resource person, Dr. S. Rajkumar. Thank you, sir. The virtual platform is now yours.
Thank you, sir. Thanks for a nice introduction about me. Fine. Today, I am going to handle the session about the generative AI. I will share my screen within a minute. In meanwhile, I will speak. Okay, it's connecting in my machine. It's taking some time. Fine. So how I have made my PPT in the today's session is, I'll start from the AI, followed by machine learning, followed by deep learning. From deep learning, how generative AI is evolved. So that's the thing I am going to share here. And in the generative AI, I am going to explain deeply on why generative AI is needed, what is generative AI, how it differ from deep learning model, and what are the core components for the generative AI. And among that 4 components, there are 2 components I plan to explain briefly. Then followed by that, I have planned how to work on some of the generative model. One of the thing I have planned for the ChatGPT. The another one I have planned for the how to generate the images from the existing images, that is called as a generative advisory neural network. So these 2 I have planned today to cover, in addition to the theoretical session in the form of demonstration. So that's the thing I have planned in my session. So with this brief introduction about mine, now I will share my screen and then I will present my session. Okay, sir, I have joined in my laptop. Can you make me as a presenter?
Yes, sir. I already did. You can share.
Okay, fine. I think it's taking some. Sir, is my screen is visible?
Yes, sir, it is visible.
Okay, sir. Fine. So my session in this FTP about the generative AI. So in the generative AI, what I am going to present today is from the scratch how the AIs are evolved. So from that, I have planned to explain. Fine. I think it's loading. Fine. So first one I have planned for the AI. See, what is AI? Can anyone can say about what is the AI? Can anyone can say? Is my voice is audible?
Sir,
Yes, sir.
no problem. The people can share their responses in chat, sir.
Oh, okay, fine, sir. Then the time will go away. Fine, sir. So my outline presentation, this is the thing: introduction about these models, and then artificial intelligence, basic machine learning, deep learning, generative AI, and case study and demos. Fine. So what is how the generative AI is evolved? You can see like here is a one Venn diagram. In this Venn diagram, you can see the outermost is the AI. So the subset of this AI is called as a ML. The subset of ML is called as a deep learning. Now the subset is evolved is like a generative AI. Generative AI. So what is this? I will say one by one. So this is the way of evaluation, and you want to know how they are having the relation. So how they are having the relation? This is the superset. Within that we have the subset, and within that we have another subset. Here we have the another subset. Now how they are related in terms of tree, in terms of visualization. So you can assume as a artificial intelligence as a tree. Is it clear? Within the tree, you are aware there are a lot of branches are there. Each branch are here we may call it as a separate topic. One is called as a natural language. Another one is called as a explainable AI. Next one is called as a deep learning. Within the deep learning, we have the another branch that is called as a deep learning. Then we have the generative AI and large language model. So in the 10 decades back, the peoples are studied only artificial intelligence. That means only the root. The nobody studied about the how that root is evolved and how it's grown and how it has given the information, how it's given the fruits and flowers and leaves. But now the peoples are learning about the each branches, how that evolved, how the growth is happened. So that is the way of the relation between the A and the ML and the DLs are here combined. Okay. So nowadays no need of to learn the AI. So if you want to expert on the particular domain, you have to go to that particular domain. You can explain. You can explore more. But before go for exploring more, you have to know the how that model is developed. That machine learning you are going to learn about the machine learning. Who is the base for the machine learning? How it's evolved? That's that basic knowledge you have to aware. So then only is easy for you to understand about that machine learning or deep learning. Otherwise you cannot understand the basics about the deep learning and the machine learning. Okay, so that's the reason I have brought the structure like this. So if you want to know how it's evolved, so this is the way of evolving and the relation is happening. And that now I move on to that some 3 or 4 slide I have about the artificial intelligence. Next some 10 slide I have machine learning. Next 5 to 10 slide I have the deep learning. Then I have gone to the generative model. Okay, fine. So artificial intelligence is nothing but is a branch of study, is a branch of computer science technology. Fine, what it will do, it is the capable of performing the some task like human intelligence. So how our human intelligence work, the same way the artificial intelligence will work. How that artificial intelligence is working like the human. So in order to work like the human, in the artificial intelligence, we have the concept, we have the algorithm, or we have developed the machine using learning, reasoning, making decision, solving problem, understanding the language, and perceive their environment. So what it will do, it allows the machine, the AI machine has to allow to do learn like human, to do the reasoning. So you are going to do some reasoning work. So same way, and you have given some data, you want to make the decision. So for the such a task, we are going to use the machine learning, we are going to use the AI. How that AI is going to do this like the human? In order to do that, there are many models are there. Very basic model to do the learning is called as first order logical derivative. I hope you might learn this in your discrete mathematics, or even if you are not aware, the simplest word, if then else statement. If this is happen, then this is going to happen. So if this is happen, due to that this is going to happen. If then else statement. For example, today in the Pune is going to rain is happen. Due to that, if uh, if heavy rain is happened today, the tomorrow exam is cancelled. So here the if then else statement. We have the if then else statement. Is it clear? So that is the one of the first order logical derivative. The in the older days, to do the learning, what we did, or to make the decision, what we did, we have used the if then else rule. But using the if then else rule, you cannot solve all the real time problem. Is it clear? So that's the reason the next order they have developed the higher order logical thinking problem. The next they have brought the production rule. Then they brought the semantic rule, fuzzy logic, neural network, and the hidden Markov model. These are the some of the AI representation. Basically, these are the some of the AI representation. Using this model or using this technique, if you are going to solve any of the real world problem, they are called as a AI model. They are called as a AI model. Next, we move on to how we can implement this AI model. In the older days, for implementing the AI model, we had the one specific language, sir, Prolog, Lisp, and ML. Is it clear? But that are all now outdated. Now there are many other AI building packages are there. Now the Perl, C++, Java, C, Julia, and JavaScript, even Python also is accepting that AI model. From this AI, now that next model is ML is evolved. ML or other models are evolved. How is evolved? From this AI, so this is my AI. From the AI in terms of perception, wise, we have developed the NLP and the computer vision. We have the developed the NLP and the computer vision evolved. So from the AI, these two domains are evolved. So these two domains are in terms of natural language processing. These are evolved right now from the AI. Similarly, for image kind of things, this is evolved. Is it clear? And if you want to do any cognitive thinking, so this and all is brought. In the cognitive thinking and learning, the subcategory is called as a machine learning. So within the machine learning, we have these are the subclasses. We have the sub learning model. They are supervised, unsupervised, then reinforcement learning, and say semi self supervised learning. Okay, or we can have the transfer learning. So these are the things are evolved. Similarly, if you want to know in terms of behavior purpose, so these are evolved. So AI is evolved like based on your need. So sir, I want to use AI for cognition and learning. Then you have to go for this type of technique. Is it clear? So if you are going for learning, then you have to go for machine learning. Cognitive things, you can do this. Similarly, sir, I want to do perception, I want to do visualize, or I want to do analyze on some natural language data, you have to use this technique.
For image, you can use, sir, I want to do behavior like human. Then you have to go for the robotic application. Okay. So this is the way evolved. Next, I move on to the machine learning. So from AI, these are the things are there. But right now, to go to the direction of generative AI, I have to go for the machine learning. So that's the reason now I am going for the machine learning. So machine learning is the subfield of the AI, and what it will do, it's able to learn without explicit programming. So please note, this model, the ML model will do the learning without any explicit program. No need to do specific program for this. Is it clear? Then how it will, then how that model is developed. The model is developed from the computational learning theory and pattern recognition model. Okay, if you are not understand this, you can see one example, from that you can understand easily. Okay, so this is the one of the example for how the ML do the learning than the AI model, existing model. So in the AI existing model, the very basic one I said, if then else rule I said. Is it clear? Or the still simplest one, you are going to develop the one program or one system for doing addition of two number. Is it clear? So addition of two number you want to do. So if you want to do addition of two number, you want to feed it into the computer machine or any simplest AI model. Okay. So what we have to do, we have to pass the two number. We have to pass the two number for addition of two things. So that is the data. And we have to define rule. So what is the rule we have to define? To perform the addition of these two number, you have to perform the rule. What rule we have to define? We have to rule the define. We have to define the rule as plus. We have to define the rule as plus. So in the system, we have to give the rule as well as the data. What is the output we are going to get? The addition of these two number used based on this rule. So that is the thing we are going to do. We are going to get in the simple computer machine. In the simple computer machine or simple AI model, we are going to do this. So what I am trying to say, I am framing the rule for the data. Today is rain, tomorrow is holiday. Tomorrow is holiday. So for that, if then else rule I am framing, the answer is we are going to derive tomorrow is holiday. Is it clear? Tomorrow is holiday, we are going to derive. Is it clear? But what is the machine learning is going to do? What is the machine learning going to do? We are going to feed data 2 and 4. Another one is output is 6. We are going to feed only the data in the form of only input or input and output. Both we are going to feed. Both we are going to feed. Is it clear? What is the machine learning going to do? It's try to derive the model, means try to derive the rule. So in order to get from this input, this is the output, we have to do this type of operation. So that is the thing is doing by the that is the thing is doing by the ML model. Is it clear? ML, what it will try to do? Take the data and then it's derive the rule. But what is our earlier or traditional AI model will do? Take our data and rule and provide the output. So this is the basic difference between our traditional AI and machine learning model. Machine learning model. Okay. Sir, you are saying we are going to feed the data and the machine learning is doing something, then is doing the derivation. How is doing the learning? Okay, how it's doing the learning. So that's the thing we are going to see in the next slide. So we are going to see in this slide. So how we are going to do the learning? So the learning we are going to do, there are 4 ways in the machine learning. One is supervised learning, another one is unsupervised, next one is semi-supervised, next one is reinforcement learning. Before move on to this learning, we have to know how we can feed the data to our machine learning model. We can feed the data to our machine learning model. There are 3 ways. One is learning from experience. So just we are going to learn from the experience. For example, what I am going to do, so I am watching something in front of me, whatever going to happen. So based on that, I am going to learn in my brain. So I am going to learn from my brain. So that is one way of feeding the input for my machine learning model. The second way is we are going to give the instruction, do this, don't do this. So that is the second one. The third one, just I am going to give the data to you. From the data, you have to learn by yourself. You have to learn by yourself. So these are the three ways we can feed the data to our machine learning model. Okay, we are going to feed the data to our machine learning model. Fine. And so any one of the format we can do we can feed the data to our machine learning model. Now machine learning model, what it will do, it's going to learn the data. It's going to learn the data. For learning the data, it may use any one of these model. Now we will see what is supervised learning model. So in the supervised learning model, when you are going to give the data, we have to give both your input as well as output. So input in this is called as the picture, the Tom and Jerry picture. Output, the output is called as a label. So label. So this picture is Tom, that is called as a output. So this picture is Cherry, that is the output. So in the supervised learning, for learning, we have to feed both input as well as output. So output means I am going to say this picture is Tom, this picture is Cherry. So both input and output, here we may call it as a output is called as a labeled data. Labeled data. So I am going to give these two to my machine learning model. My machine learning model. For example, your now I am doing teaching learning process is one of the best example for the supervised learning model. Teaching learning process is one of the best example for the supervised learning model. So what I am trying to say here, I am feeding here. So this is Tom is label and this picture is called as the input. Is it clear? This picture is called as a input. I am insisting you. So here I am insisting you. So this is called as a Tom. This is called as a that corresponding label. I am insisting you. This is called as a supervised learning data. This is called as a supervised learning data. So whatever I am going to insisting, that in your brain, the machine learning algorithm is going to feed. Okay, this picture is Tom. This is corresponding label. It's feed it in your model. So what your model is going to do, it's going to learn like this. It's going to learn like this. So that is the thing is happening in your supervised learning model. Okay, in the supervised learning, what we are going to do, we are going to learn the data along with label. Okay, along with the label. That is the thing. So still, if you are not clear, see simplest word in the AI model, what happened? I have to define some rule. With the rule, you cannot get the good accuracy. So that's the reason we are going for the next model, ML model. In the ML model, I can feed the data either in the form of just a raw data, or I have to feed some instruction, or I have to learn from the experience. The supervised learning is one of the example for learn from experience. Okay, one of the example for learning from the data. One of the example for learning from data. So how the learning is happened? So for the learning phase, there are two things are there. One is training phase, another one is testing phase. Another one is testing phase. What is by learning means? Best example, the teaching learning process. Okay, right now I am teaching you the generative AI model. I am teaching the generative AI model. So I am saying this is the word is supervised. This is the word is algorithm. This is the word is learning. I am insisting you. So that and all you are putting on your brain. That and all you are putting on your brain. That is called as a training. Now I want to check how your supervised learning is happened properly or not. How do I do? At the end of the session, I am going to ask some question to you. If you are answering my question, then you are learn 100%. You are followed my instruction, or you are followed my guidelines. If are not answered, I have answered, I have asked the 4 query, but you have asked only 2 query. So that means only 50% learning is happened. So you have to keep it in your mind when you are going to do the machine learning model. In the machine learning, there are 2 phases are there. One is training phase and the testing phase. Right now, I am showing only the training phase. In the training phase, we have to feed the data. When I am going to feed the data in the supervised learning, along with the data, I have to say this data is generative model, this data is machine learning model, this data is AI model, this data is deep learning model. That label I have to give for the learning. Is it clear? So based on that learning, we are going to do testing later. Okay, we are going to do the testing later. So this is called as supervised learning. Next way of learning, unsupervised learning. What is by unsupervised learning? Just I am saying the only the guide, only I am giving the content. I am not saying this content is belongs to generative AI, this content is belongs to AI, this content is belongs to machine learning, this content is belongs to deep learning. I am not saying. I'm simply I am giving the keep on, I am giving the content to you. Is it clear? Now, what is your brain has to do? Your brain has to automatically has to interpret the data. Based on the interpretation, it's going to form the label. It's going to form the label. So that is called as a unsupervised learning. Here in this example, I am feeding just this type of unknown data. Unknown data. So what is your brain has to do? Interpret by itself and then group this as a one group and this as a another group, this as a another group, and then label this group as a one or this group as Jerry, this group as a Tom, this group as a Tom. So now what is the unsupervised learning is doing? It's take the data and then is forming the group. Now this group is called as a, this group name is called as a label. Now you can look, this data is looking in the form of this one. See here, I have the picture along with the label is Tom and Cherry. Same thing I am going to get as a output. So what is mean by unsupervised learning? We are going to feed only data. We are not going to feed the label. So what is the unsupervised learning? Always will do one step extra than the supervised learning model. So what is the one extra step? First, it will interpret the data. It form the group. After forming the group, this is going to act like this guy. Then whatever we have did on the supervised learning, the same thing we can do learning here also. After learning, we can go for the testing. We can go for the testing. So this is the basic difference between supervised and unsupervised. In the supervised, we are going to give that input as well as that label. Label is called as output. But in the unsupervised, we are going to give only the unlabeled data. We are not going to give the label at all. We are going to frame the label from the given data. That is called as unsupervised. What is by semi-supervised learning means? So we are going to have both supervised and unsupervised. That is called as a semi-supervised. That means half of the data we can have the both input as well as the label. Another half we can have only the data alone. We are not having the label. It's clear, we are not having the label. So that is called as a unsupervised learning. Next one is called as a reinforcement learning. To explain the reinforcement learning, I am going to take one scenario. Assume we have dropped you in the isolated island. We are dropped you in the isolated island. What is your expectation, or what is your behavior there? So what will you think? First one, I will think first one, I want to live in the world. That is the thing. Second one, I want to escape from this island. Is it clear? I want to escape from this island. So what do you have to do for this? So you are first, if you want to escape, you have to live. You have to alive. So for aliving, first you are going to search the food. You are going to search the food. Here, food is called as a input for the your reinforcement model. Here in the reinforcement model. So the food. So you are taking the food and you are behaving for that food. So what is the behavior you will do? Tasty. It's bitter. It's not, it's not tasty, or it's not worth for getting the energy, not worth for getting the energy. So based on that, you are going to draw the one state model. See, I will repeat. You are right now in the island. So what is your expectation? You have to live and also escape. So how do you live? You need the food. How do you escape? You need the some of the transport. So in order to do that, what do you have to do? First, in the environment, you are going to search. So this is the environment. Assume this is the environment. So in this environment, you are here. So what you are going to do? You are going to search the food as well as the transport. So you are searching some food. Okay, these are some food. These are some food, and these are some transport. These are some transport assumption. Is it clear? Now what you will do? You are going to take this guy, and you are going to do some action. So through that action, you are going to do the some. You are going to do some action. So this is, you are a person. You are going to take this food. Okay, you are going to take this food. Okay, that food, and you are going to reach some state. You are going to say the reward, the positive reward. You are going to go there. If it is negative reward, you are going to stay here itself. And now in the second stage, you are going to get next input. You are going to get the next input. So you are going to get second input. Based on the input, you are going to get some reward, or you are going to do some action. Based on the action, you are going to get the reward. Reward means I am going to reach that new destination. That means my lifetime for increasing due to that food. Okay, due to my food. So like this, you are going to draw one complete automata. You are going to draw one complete automata. So that is called as a training. That is called as a training. Okay, that is called as a training. Is it clear? And what is the reinforcement learning testing will do? Now you will feed the new input and test on this model whether you are able to alive, or whether you are going to come out from the island or not. So this is the thing is happening on the reinforcement learning. In the reinforcement learning, try what it will do, using the environment as the input. Based on the environment, you are going to do some action. So based on the action, you are going to get the reward. Okay, so the reward is going to form the structure. You are going to form the structure. So that is called as a learning. That is the way of control system, or that is the way of you are going to do the learning on the reinforcement model. Okay, we are going to do the in the reinforcement model. Is it clear? Now I will move on to that learning in the summary. Okay, so in the summary, what I am trying to say, what kind of input we have to feed. So these are input on those model, and based on the input, what type of algorithm you can use. What kind of algorithm you can use on those learning model. Okay, suppose you are going to use supervised learning model. So in the supervised learning model, you are going to give the continuous data, continuous form of data. Then there you have to use the algorithm is regression algorithm. Similarly, if you are going to feed the categorical data, you have to feed the classification algorithm. Is it clear? So what is the supervised learning going to do for the categorical data? It will implement the classification model. Through the classification model, it will try to learn the data. It try to learn the data. For the given data, we are not going to get any output. We are going to learn the data. Please note of that. Then unsupervised learning, we are going to feed the data in the form of without a target, without labeling. So for that, either you can use clustering algorithm or association. Similarly, for semi-supervised learning, we can give the data categorical target variable. You may get the output as classification. You may use the algorithm, classification algorithm or clustering. You can use it. Similarly, for reinforcement learning, we can feed the data in the form of categorical target variable or no target variable. Both you can feed. If you are going to use no categorical data, then there you have to use classification model. If you are going to use the no categorical data, we are going to use the control model. Okay, we are going to use the control model. The summary of that model, that whatever I have previously explained, the same thing is given here. between AI and ML. So in the traditional AI program, we are going to give the input as well as the logic. So we are going to get the output. But in the machine learning model, what we are going to do, we are going to give this input and this output, and we are going to derive this logic, and we are going to check whether this learning is happened properly or not through some test data, and then we are going to do the output. So this is called as a machine learning. So in the machine learning, rather than doing if then else rule or any of the direct mathematical model, we are going to derive some of the mathematical model from the input data. Okay, so that is called as a machine learning. The next we move on to the deep learning. So deep learning is the subset of machine learning model. Okay, subset of machine learning model. Here, this subset can use the multiple layers in its neural network. In its neural network, it will use the multiple layer. Okay, multiple layer, and it will learn the complex pattern, Sir, how you are saying it's learn the complex pattern? For that, I have given one example here. You can see here one picture. In this picture, we have this some of the sub picture. So the sub pictures are contains either puppy or paggle. Now, if I am going to give this kind of picture to my machine learning model, it cannot recognize. It cannot recognize. Why? That reason I will say in the upcoming slide. Right now, we can note. Okay. So why? Okay, fine. So why deep learning model means this type of complex picture you cannot our machine model cannot discriminate. For example, whether this is the puppy or paggle, but using your human eye you can predict, but how the machine can do, machine cannot do. So such a this kind of task we need the deep model. You may see one more example. I have here sheepdog or mop. Can you identify here who is the sheepdog or mop? This also is difficult. Okay, and that how this deep model is taking up. When your amount of data are increasing, to learn those data and also bring the performance better way, we need the larger neural network model. That model is called as a deep learning model. See why you are saying amount of data are increasing nowadays. See, you can go for 10 years back, whether you have the mobile phone with you, or you can go 15 years back. See, you are a childhood. That time, did you use that mobile phone? No. You can now you can see the parents, their children's, the 1 year children are using the phone. Is it clear? So now the technologies are evolved. Through the technologies are evolved, the amount of data are increasing. When the amount of data are increasing, their complexity also increasing. When the complexities are increasing, our traditional AI model can't give the expected result. So then we need the better model. That's the reason we are going for a deep neural network. The deep neural network is called as a deep learning model. So in the deep learning model, we need the lot of neural network. Model. Through that only you can bring the better performance. So that's the reason you can see when the amount of data are increasing, my larger neural network model is given the better result. Okay, in the performance wise. Fine. Next I move on to what are the architectures are there in my deep learning model. Sir, you said the deep learning model we are going to use for the complex pattern. Okay, we are going to use for the complex pattern. Fine, we are going to use for the complex pattern. Now, how that complex pattern is realized or analyzed? Okay, for that we have developed, there are different kinds of model. One model name is recurrent neural network for the purpose for speech recognition and handwriting recognition. Speech and handwritten recognition we have used. Similarly, we have developed LSTM, longest short-term memory, for the purpose for natural language text compression, gesture recognition, image caption. Similarly, we have developed for CNN convolution neural network for the purpose for image recognition, video analysis, natural languages processing. Deep belief network for image recognition, information retrieval, failure prediction. Deep sequential network we have developed for information retrieval, continuous speech recognition. So there are many deep models that we have developed, but each model has some specific application. Based on your requirement, you have to choose the best model for implementing your problem statement. Okay, here I have given only the nutshell or one of the simplest models are present under deep architecture. Okay, and how those architectures are vary. So that structure I have given here. That structure I have given here. Okay, so here you can see in the convolution neural network we are feeding the image. So from the image we are extracting some feature. That feature we are going to feed it into the fully connected layer. Then we are going to do the classification. In the recurrent neural network we are feeding the input in the form of sentence. Fine. Then we are going to pass it to the hidden layer. Then we are going to get the output layer. This is the typical pictorial form of the CNN and RNN. Now I move on to the difference between the ML and DL. So previously we have learned difference between ML and AI. Okay, and from the ML we have some limitation. That's why we came for DL. Now we want to know how that ML is different from the DL. Okay, fine. Now, ML, how the ML will basically will work. Please note, ML model or machine learning model can take only the input in the form of raw data. Please note, only take input in the form of raw data. You cannot can't feed image or video. Image or video. Please note of that. Image or video. Fine, in the machine learning model. Similarly, you may ask, sir, what about traditional AI model? In the traditional AI model, we have used if then else rule, or we may use the probability. Is it clear? Or we may use the logic programming, that is logical programming. So there and all we cannot feed our input in the form of images and video. Is it clear? We cannot feed. So then how that machine learning model or AI models are worked? What we have did, we have manually extract the feature from the video and images. For example, you can see in this picture, input is car. So now I want to recognize what type of car. This is the whether this car is high-end car or low-end car, or whether this is come under the company Tata or comes under the company Hyundai. Is it clear? So these are the things you want to analyze. So by looking the picture, you can say, but how the machine can do? Machine do not have the sixth sense. We have to feed the sixth sense. We have to feed the sixth sense. Is it clear? We have to feed the sixth sense. So how we are going to bring that sixth sense? In order to bring the sixth sense, first I have to bring the manually I have to bring the important feature or important parameter from here. So that parameter we may call it as a feature. That parameter we may call it as a feature. Please note here. So we are going to derive the feature that is called as a parameter. So based on this parameter, we are going to do the learning. The sixth sense, the learning is going to happen. So if the parameter is not good, the learning accuracy also is low. Learning accuracy also is low. Is it clear? So this is fully depends on the user who is developing the model. Based on them only will work. Is it clear? Based on their expectation only will work. It cannot work for all. It cannot work for all. So what I am trying to say, in the DL model, in the ML model, we cannot feed the images. We can feed only the raw data. So what I have to do, I have to convert this data in the form of raw data. How I can convert in the form of raw data? I have to do some manual extraction from the given picture. Then I have to generate the raw data. Okay, the raw data may be the any parameter extracted from the image. For example, here I want to recognize the car. What I have to do? I have to extract the wheel size. I have to extract the window size. I have to extract the car size. I have to extract the area of the inner area of the car size. Is it clear? So like that, those things I have to extract, and then I have to feed it into my classifier model, machine learning model. Then I am going to do the classification. If your extraction technique is not good, then the classification performance also low. So in order to avoid this classification performance coming to the low, what we are going to do in the deep learning model, why can't I feed the input images or video directly to my model? So for that purpose, deep model is developed. In deep model, what we are going to do, rather than extracting the feature from the images or video, directly we are feeding the images as the input to our deep model. So our deep model itself do the feature extraction and classification. Okay, machine itself is doing the extraction and the classification. Then we are going to get the output. So you notice here, you notice nowadays many people are not at all thinking at all. If they are having any query, directly they are using some of the online open AI. They are getting the output. You can see that output, whatever we are getting, it's better than the human thinking. Better than the human thinking. So that is the one of the example for the deep learning is work better than the machine learning. Is it clear? Fine. Now come for the summary of the AI, ML, and DL. So AI is the subset machine learning. In the machine learning, these are the learnings are there. Then with that, I have one more thing is called as a deep model. So under this each model, what purpose they have written, and under each purpose, what are the algorithms are there, or what are the models are developed. That's and all shown here. Okay. So that's, I think, no need to explain to you. Fine. Okay. Now with these basics, now I move on to our model is called as a generative model. Generative model. So generative model evolved from AI. Please note of that. Fine. Now you have to know what is generative model. So generative AI is the branch of one of the branch of artificial neural network. What it will do, it will try to create the new data. Please note, it's try to creating the new data. Fine. You may ask, sir, what about our AI and ML and DL? Whether they are creating the data? No, they are not creating the data. They are tried to analyze the data. They are tried to analyze. So, but what generative AI will do, both analysis, after analysis, it will create the new data. It will create the new data. Okay. So what kind of data it will create? It will create the data, text, images, music, video, or code. Anything. Okay. Anything. How it will create? From existing data. It will do existing data. From the existing data, it will do. So that is the called as a generative AI. In next slide, I have given the difference between the generative AI and traditional AI. So what purpose of our traditional AI? We are going to use the traditional AI for analysis of the purpose. What about the generative AI? We are going to use for the purpose for training purpose. We are going to use for the purpose for training purpose. Is it clear? We are going to use for the purpose for training purpose. Please note of that. We are going to use for the training purpose. Then what is the traditional AI going to do for analysis? For the analysis, through the analysis, we can do any classification or we can do any prediction. Any prediction we can do. But what is the generative AI will do? It will generate the new text or new images or new code. Okay. The next one, what is the traditional AI will do? Detect the pattern. Detect the pattern. So what are the hidden or what are the noisy informations are present on the given data? So that will deduct by the our traditional AI. My generative AI will synthesize the new data. What it will do? It synthesize the new data. Example for traditional AI, we are going to detect sperm male. Okay, so that is the one. Or what about the generative AI? It will try to create the new data. It will try to create the new data. It will try to create the new data. Fine. So that is called as a traditional, that is called as a generative AI. Simple thing, you have to keep it in your mind. So traditional AI can't do any generation like AI, ML, and a deep model. Is it clear? But I want to do any generation, we have to go for generative AI. We have to go for generative AI. So how the generative AI will work? It will try to learn my existing pattern using some of the mathematical model. Then it will store it in the brain. So from the stored data, when I am going to give the new query, it will try to generate the new data. It will try to generate the new data. So that is the thing is doing by the generative AI. Now we will move on to the what are the fundamental shift in AI. Fine. In 2000 years, we have the rule based model. In 2010, in machine learning model. In 2015, we had the deep model. In 2020, we have the generative AI model. Okay, we had the generative AI model. So now you can see how in the 2000 we have used the if then else rule. What about it? In 2010, we have used the pattern recognition. In 2015, we have used for the deep speech and NLP data. And 2010, create or synthesis or bring the reason from the given data. Bring the reason from the given data. So for that purpose, we have to use the sir. Yeah. Okay, fine. So come for the shifting of AI. So in the 2000, we have used the if then. In 2010, we have used pattern recognition. In 2015, we have used the image or speech or NLP data recognition. Basically, in 2020, we are not recognizing, we are creating. That is the thing we are doing in the generative AI. How it's generating. So that's the thing I want to show in the upcoming slide. Okay. Please note the generative AI is not just an upgrade version of the our previous AI. So it is a paradigm shifting from AI that analyzes to AI that creates. Please note of that. AI from analysis to create. Is it clear? For one of the real world triggered information about the generative AI is called as a chat GPT. It's reached 100 million user in just 2 months. Please note, it's when it started from the day, within the 60 day, around 10 million people are users are there. Is it clear? Similarly, for Chat 4.0, Gemini 1.5, Cloud 3.5, multi-model, real-time, human level reasoning. So for that purpose, we have developed this. Okay, and this generative AI will generate the data you know. So you are aware there are many kinds of data are there. Image is there, text is there, music is there, video is there. Okay. Are you going to use for all the purpose only one model? No. Are you going to use for only one model? No. We may use one model, but that model, it can't give the 100% efficiency or 100% good generated data. So that's the reason the people or researchers are developing different model for different purpose. For text, I want to generate text, sir, or I want to summarize the text, sir. For that, GPT-5 is developed. GPT-5 is developed. Similarly, you want to generate the images. For images, the DAL E3 or Mid-Journey models are developed. For musical model, for music generation, Sono and Mubert is developed. For video model, video generating the video, Runway Gen 2 models are developed. The Runway Gen 2 model can produce short video clips. It cannot generate the more 1 hour or 2 hours videos on that. Please note of that. Is it clear? So these are the models are already evolved. Why these models are we want to develop? That's I already said. One reason is our traditional models are will do only the analysis, can't do the generation, can't do the generation. So that is the one reason. In addition to that, in deep learning model, in addition to that, in the deep learning model, whatever we have, those model can work with the limited amount of data, limited range of data. Okay, if your data dependencies are more, okay, the one word has the relation with the another word, the one word has the relation with the another word, the other word is has the relation with the one more word. So like that, like this type of dependency, we cannot and we cannot predict, or we cannot find, or we cannot match in the DL model. Why? Because in the DL model, just we are doing analyzing, we are not generating. But in the generative AI, I want to generate any new things. I have to relate my query with the trained model. Is it clear? I have to map the dependency. So based on the dependency only, you can get the output. So to generate the output on the long sequence and dependency, we are using our generative AI model. So how the generative AI models are generated? For generating the generative AI model, we have 4 core architecture. We had the 4 core architecture. One of the architecture is called as a transformer. The second architecture is called as a GAN. GAN is called as a generative adversarial network. The third one is called as a variable auto encoder. The fourth one is called as a diffusion model. In the diffusion model, okay, these 4 core architecture is present in your generative AI model. Okay, among these 4, we will see what is the purpose of transfer model 1. Transformer model is nothing but is the foundation of LL model, large language model. Okay, so in the large language model, we had the self-attention mechanism. We had the self-attention mechanism. Is it clear? And by itself able to has the attention. Attention means give the importance for the data. For example, in the body itself, we have the automatic curing of the problem or damages damages on the body. Same way, when I am going to feed the data, I want to do the attention on the data by itself. For that purpose, self-attention mechanism is added in the our core model on the core model of the our generative AI. What is the core model? One of the model is transformer. In that model, self-attention is added. Self-attention is added. Is it clear? Please note, in our body, we have the automatic curing, automatic digesting. Same way, for automatically, we want to control my data in my model, in my machine model. For that purpose, the transformer, we have the automated, we have the self-attention mechanism. Okay, so what is this self-attention mechanism will do? It's process the entire sequence at a once. It will process the entire sequence at the once. Is it clear? And best example for the transformer model is Chat GPT and PERT and a T5 model. The second one called as a GAN. So the GAN basically we can use for generating the images, okay. So for generating the images in the GAN, we had two functions. One is generator, another one is discriminator. One is we had the generator, another one is discriminator. Always generator, what it will try to do, it try to fool the discriminator. Okay, it will try to fool the discriminator. Okay, the power of this model is deep fake and image synthesis. Okay, so example of that model is style GAN model or deep fake models are there, already existing models are there. Okay, the next one is called as a VAE. VAE is called as a variable auto encoder. VAE is called as a variable auto encoder. We can use variable auto encoder for the purpose for image editing or discover the pattern on the given data. Fine. The next one is called as a diffusion model. The diffusion model, what we are going to do, we are going to add some noise on the data. Is it clear? And we are developing some model, and we are going to check our model how long resistant or it's reliable on the given noise data. Okay, so for that example, we have stable diffusion model and so on. Okay, so these are the four components are there. But now in this lecture or in this session, we are going to see briefly about this and this. Only about these two model we are going to see. Fine. And before move on to those model, I want to say what are the different kinds of generative AI models are exist. Okay. For example, your purpose, you want to do any text to text generation or text generation. That means you are going to give some text. For that, you want to generate some other text. For that, we had the model Chat GPT model. This everybody aware of that, and Llama model, Llama model, and Glad model, and many more model. But now we are familiar with this Chat GPT and Llama model. Okay, and Glad. So this is we familiar. Similarly, from the text you want to generate the any images, we can use Midjourney, Muse, ImageZen model. Is it clear? Similarly, image to text generation, we can use Chat GPT, Visual Art, and so on. Image to 3D model, you want you can use Dream Fusion or Magic 3D. Similarly, image or video to 3D model, you can use CSM AI model. Similarly, you want to do text to speech conversion, we can use 11 Labs or you can use Murph AI audio LM. Similarly, you want to use speech to text. You are going to do speech and you want to convert in the form of text. We can use Whisper. Okay. So these are some of the models are there in real trend now. Based on your problem statement, you have to select the particular model and then get the information from them. Okay. Next, I move on to that core component, explaining about that core component. Okay. So how the generative AI will work, either it will work in the form of transformer model or diffusion model or GAN model or variance encoder model. Variance encoder model. Yes or no? Encoder, auto encoder model. So these are the 4 models are there. Any one of the model your generative AI will use. But right now in the ChatGPT and all, we are using transformer model. And before go for learning about in depth about the transformer model, you want to know what kind of learnings are they are doing, whether they are doing supervised learning or unsupervised learning or reinforcement learning. Please note, for the learning, for the training perspective, we are using unsupervised and self-supervised model. For beginning, we are using unsupervised. Unsupervised means simply we are giving the data. From the data, it will generate. From the data, it will form the group. How it will form the group? It will analyze. And after forming the group, your formation is not good, then you want to fine tune the model. For that, we are going to use the supervised model. Supervised model means we are going to feed for this place, these changes you can do such a way that the learning is going to happen good. Similarly, we are going to do reinforcement learning from human feedback. Okay. See, you are going to feed some, we are going to give some feedback for getting the output from the, whatever output we are getting from the chat GPT. So based on that, it's automatically it's going to do, that is called as a reinforcement learning. So basically in any generative AI model, all the all those learnings are there. In the basic model, we are going to use unsupervised and self-supervised model. For fine tuning, we are using the supervised model, and we are going to feed the new data, or we are going to give the some of the reward, whether it's good or bad. Okay, based on that, it's automatically it's going to do the learning, that reinforcement. See, all these 3 are playing in the generative AI model. All these 3 are there. Don't confuse, we have only supervised or unsupervised. We have all the models. Okay. Now I move on to transfer model key concept. What are the key concepts are there in my transfer model? In my transfer model, we have the key concepts are encoder and decoder. We have encoder and decoder layers. We have 1. Is it clear? Encoder and decoder layers we can have. The next one, we have self-attention mechanism. The third one, we have the tokenization. These 3 are playing major role in the transformation model. What purpose for encoder and decoder? Encoder and decoder we can use for processing your given sequence and generate the sequence. For processing and generating purpose, we are going to use our encoder and decoder model. And I want to focus on some particular important data. So on the given data, for that we have used self-attention mechanism. We have used the self-attention mechanism. So what is the self-attention we can do? It will focus on important words on the given text sequence data. Is it clear? So for that we are using self-attention mechanism. Then in order to focus on the given, in order to focus on the specific word, what we have to do, we have to separate the our given sequence. For the separation, we are going to use the tokenization. So what are the main three core component on the transformation? First, we have to split the data in the form of token. So for that, we are using tokenization. Next, we are going to do analyze the specific token. For that purpose, we are using the self-attention mechanism. Then we are going to learn that complete data. We are going to use encoder and decoder model. How these models are working. So that is given here. The step one, we are going to take the data. From the text data, we are going to generate the token. We are going to generate the token. So first step we are going to do in any generative AI, generating the token. The second step, what is the second step we are going to do? We are going, what is the second step we are going to? We are going to create the vector. We have to create the dense vector. How we are going to create the dense vector? We are going to create the dense vector with the embedding matrix, with the embedding matrix on the token, on the generated token. On the generated token, we are going to add the embedded vector, embedded matrix. Through that, we are going to get the dense space, dense vector, or we may call it as a vector space, vector space or vector space. Now that vector space we are taken for predicting the next sequence. See, the transformer learns to predict the next token in a sequence. So now using this embedded matrix, we are going to predict the next word. So this is called as a self-attention. The next, after training, the model can generate the new text. Model text will generate the new text. So that is called as a decoder. That is called as a decoder. So these are the four steps are playing on the our transformer to generate the data. For example, you can see the cat sat on the dash. You are asking the chat GPT or you are asking any generative AI model to generate what should be come on the filling the blanks. So either it will generate the token sat or flow. That depends on how the learning is happened from the our previous data. Okay, on the previous data. So based on that, the transformer will work. The next we move on to the GAN model. What is the GAN is going to do? Its GAN is generate that new data from the original data. From the original data, it will create the new fake data. So that is the purpose we are going to use the generator. What is the use of discriminator? Try to distinguish between real and fake data. So what is the discriminator going to do? It's try to recognize whether the given data is generated or it's created by the human. Okay, so that's the difference it's going to do by the discriminator. The training phase, we are going to learn the data. How we are going to learn data, that and all I'll show in the upcoming one. The diffusion model, what we are going to do, we are going to randomly add the noise. So, and we are going to try to develop the model to remove the noise. Okay, so that is the called as a diffusion model. I am not going to focus on the diffusion one. I am focusing only on the transformer and GAN model. Now we'll move on to the transformer. In the transformer, we saw there are four key components four key concepts are there. Okay, and the key concept, in the key concept, we have major two component. One is multi-head self-attention, another one is feed-forward network. Another one is feed-forward network. Okay, and note on each layer also we are going to include layer normalization and residual connection. We are going to include both layer normalization and residual connection. Please note of that. Is it clear? In practice, GPT style model uses the decoder only transformer, while model like BERT's using encoder only once. encoder only once. Is it clear? Fine. Now I move on to the block diagram of the my transformer. So what is the block diagram? We are going to give the input. From the input, we are going to generate the for the input, we are going to generate the embedded vector matrix, embedded vector space. So how you are going to do that? For that, we are going to create the embedded matrix. Embedded matrix is nothing but the weight matrix. And from that, we are going to do the learning. We are going to do the learning through the transformer. After learning, we are going to generate the output projection. And finally, we are going to produce the output. This is the typical transformer model. Typical transformer model. So in the transformer model, we are aware already we have two things. One is encoder, another one is decoder. So these parts are called as encoder. These parts are called as a decoder. Okay, these parts are called as a decoder. Fine. Okay. Now, how that my transformer is working for generating the data? Fine. First, we have to feed the input. From the input or on the for the given input, we are doing embedding. Followed by we are doing positioning encoder. What is this? I will explain in the next example or in the next slide. The next followed by position encoding, we are going to perform multi-head attention. We are going to perform the multi-head attention. Within the multi-head attention, what is going to happen? So that's shown briefly here. Fine. So that is we are going to explain here. Is it clear? So multi-head attention we are going to explain here. So what is the multi-head attention will do? It will focus on the important word to generate the our new content. To generate the our new content, it will focus on the new word. So how it will work? For that, we are going to give 3 input from the embedded input matrix. One is called as a query, another one is called as a key, another one is called as a value. So these 3 we are going to feed. Among these 3, we are going to perform the scalable dot product. We are going to perform the scalable dot product. We are going to perform the scalable dot product. That dot product we are going to concatenate. Then we are going to generate the linear one. Then we are going to generate the linear model. That linear one, we are going to feed it into the ADAM norms. Odd and norms. Odd and norms. Is it clear? We are going to give it to the ADAM norms. So what is that ADAM odd and norms will do? Like we are going to use activation function in our deep model. Same way here we are going to use activation function and norm function and that result we are going to take and feed it directly to the feed forward network, as well as that feed forward network result is add with the my previous result. Similarly, you can see here when I am going to add the multi-head result, when I am going to send my multi-head result to the my feed forward, we are going to add that result with the my original data. Then we are going to send. So this is the way embedding can work. Embedding means learning. So for the learning, we are going to use the input data and embedding matrix and position encoding, followed by multi-head attention, followed by we are going to use the add and norm. So using this, we are going to work. And note these add and norms. If you want, you can use more level also. That depends on your data. You may decide what kind of what are the numbers of levels or number of levels of multi-head and odd is recovered that you can add based on your requirement. Then you can make it. So that is the thing is called as a encoder. So encoder. What is the decoder will do? The decoder, we are going to give the output. That means query. There also we are going to perform same thing like input embedding. Here also output embedding and encoding, positional encoding. We are going to do masked multi-head attention. We are not going to do the multi-head attention. Masked means some of the words are is hidden. So that word we want to predict. That word we are going to predict. That word we are going to predict. So for that we are going to use the masked multi-head attention and add and norms we are going to do. And this add and norms. This is the our query. This is the our query. Query we are generated output using this. That generated one we are going to combine with our encoded already trained one. Now in this multi-head attention we are going to relate each word on the output, how it's depend on the words present on the my input data, then we are going to form the dependency. That form the dependency that output we are going to feed it into the next feed forward network. So like this we can do. And finally we have to bring all the our feature in the form of one vector. Is it clear? So that is called as a linear, and that vector is given to the input to the softmax. For softmax we are going to use for only for classifier purpose. Only we are going to use for classifier purpose. Is it clear? So softmax we are going to use. Then what is the softmax will do? The classifier. What kind of classifier will give us a output? It will give the output the probability of the each data. The probability for query data, whether this given data is, whether the for the query data, whether how long this query data is relevant to the your trained model. That the probability is given by the my decoder part. So this is the one of the typical transformer architecture, and within that architecture we have the core component is called as a multi-head attention. That multi-head attention working functionality is given here. That within that multi-head attention, how the dot product is happen. So that is explained here. Fine. Okay. Now with this architecture, we'll move on to the one example of one example for transformer. Okay. So the one of the example here I have taken, generate the next word for the given test data. So before go for testing, first we have to train the model. Here for the training, we are going to use the transformer model. We are going to use the transformer. Okay. So in the transformer, we have to feed the input. So I am going to feed the input, the cat sat on the mat. I am going to feed the input, cat sat on the mat. Is it clear? I am going to feed the input, cat sat on the mat. Fine. Okay, fine. We have feed it. Now, what we have to do? We have to learn this. For that, what is the transformer will do? First, it will do tokenize the data. First, it will make it as a token. Fine. Token means it will separate the each word. Fine. That separated tokens are shown here. Fine. The next step, we are going to do vector embedding, and followed by we are going to do positional encoding. Here I am going to explain this overall overview steps for processing this one. Okay, the first step is tokening and embedding. Second one is encoder. What is the encoder will work? What is the purpose of encoder we are going to use? Each word looks at all other word to understand the context. That means how each words has the relation. That's we can deduct using encoder. That is called as a self attention. Third one is called as a decoder. Third one is called as a decoder. Okay, that is called as a masked self-attention. That is called as a masked self-attention. So in the masked self-attention, we are going to give the our test data. What is my test data? The cat sat on the. I want to predict next word. So this data, along with this learned data, both are is taken into decoder. From that, it will generate my next data. Okay, it will generate my next data. So what it will do, it will take input of my both my test and my trained encoder model, and it form the relation. And what is the encoder and decoder attention will do? It will try to generate the possible all the combination. And what is the output will do? It will say the from the all the possible combination whose highest probability is more, that will be generated using the softmax layer. Highest probability. Okay, so how these steps are going to happen one by one elaborately I will show in the upcoming slide. Is it clear? The first step in the transformer, we have to do tokenizing. So this is the tokenized for this given input. For the given input, this is the tokenized. Okay. Next, what we are going to do, each token, we are going to map it into a unique ID. Each token, we are going to map it into the unique ID. That is the second step. So for example, for this, I am going to give the unique ID 1, 2, 3, 4, 5, 6. Fine. Okay. Now this each code is converted in the form of numerical embedding vector. Numerical embedding vector for the purpose of to know the semantic meaning between the each word. To know the semantic meaning between the each word. How we are going to get the semantic meaning? Using embedding vector. So that embedding vector is nothing but the weight matrix. It's nothing but the weight matrix. So what structure you are going to give the weight matrix? So based on that structure, you are going to get the output for the each token. We are going to get the output for the each token. Is it clear? We are going to get the output for the each token. Now that, okay, now I will take one assumed embedding vector weight matrix is this, and my token for this is 1, and this is 2, and this is 3. Assumption, everything. Cat is 1, okay, sat is I have given there 4, and token is 2. So token is 2. I have generated. Fine, I have generated. Now these tokens are embedded with this weight matrix. That embedded weight matrix we are going to concatenate, or we are going to add with the positional encoding. Why positional encoding is needed? The generative AI transformer does not have the memory. Please note, it does not have the memory. So that's the reason it should not, or it could not know what is the sequence of the word. So in order to know the, or in order to make the remembrance on the transformer model, we are using positional encoding. What is the positional encoding we will do? For each token, we are going to assign the position. So this is position 1, this is position 2, this is position 3. So like that, we are going to assign the position. Based on the position, we are going to form our final output along with my basic guide. My basic guide. Is it clear? So now I am going to do positional encoding for understanding the sequence or know the sequence. Is it clear? Now I will add this with my embedding word. That is the output we are going to get in the first step. The second step, what we are going to do, we are going to know the probability or dependency of the each word. on the given data. This is my given data. This is my given data. To generate the each word, so what we are going to do, we are going to develop the self-attention mechanism. What is the self-attention mechanism? It will project the my embedded and positional data in the form of three ways. One is query, another one is learning, query, another one is value, next one is key. So these are the three. So using these three embedding matrix, we are going to find the attention score with respect to all other words. So I am going to find the self attention of each word with respect to all other word, with the respect to all other word. In order to do that, we need the three embedding matrix here. One is query, another one is key, next one is value. By using these three, you can compute the your attention score of the each word. For finding the attention score, this is the formula. Now we have to know what is Q, what is K, what is V. Okay, so that's and all here. To generate this, we are going to generate the embedding matrix. So these are the embedding matrix value, and using this I am going to perform the dot product with the my positional encoded output. So this output I am going to perform with the dot product with the weight matrix of my query, key and value, and that values are we have rounded, and this rounded value we are going to use it for the score calculation. We are going to use it for this score calculation. So that is shown here. Okay, the formula. So now if you substitute this value, okay, you will get that score. On that score, you are going to apply the softmax function. Then we will get our output. Our output of attention weight matrix. So how each word has the relation, that weight matrix we got it. Now this weight matrix, we are going to get us a output for each word. For getting the output for each word from the attention score, so this is the formula. So from this we know what is the output for weight matrix of my cat word. This is the word 2. Is it clear? Now this is output, we are feed it into the feed forward network for the learning purpose. Feed forward network. So the feed forward network from formula is this one. Is it clear? By applying my input X with my new matrix plus bias, that I am going to perform ReLU. That ReLU one I am going to multiply with my weight matrix 2 plus adding bias. I am going to get the score for my f of n, the feed forward network. That one we are going to norm. We are going to apply the norm operation. So that is written here. Here layer norms of original data plus feed forward data. Feed forward data. Okay, so that's output we have stored. And similarly, now we stored on the training side. Now decoder side, what we have to do, we are going to give the query. What is my query? I want to find the cat sat dash. So where is there? Fine. So for that we have to pass the query. We have to pass the 3 token. So here we have passed the 3 token. One is the second one is cat, next one is sat. Now you want to predict. The next word. For the prediction, what we are going to do, we are going to take this word. For these words also we are going to assign the token key. For the each key we are going to assign the embedding matrix. Through the embedding matrix we will get the value. for the getting the value, we are going to add the positional encoding. The positional encoding output for that we are going to calculate the attention score. For attention score calculation, we are going to use the masked self attention mechanism. Okay, masked self attention mechanism means when I am going to use my first word, for first word I am going to use only first word, the remaining word we do not know, that's why it's disabled. Thus, when I am going to form the second word, so I have to form the relation with my input with the first two word. So that is shown here. The third word is unknown. Similarly, for my third step, all my three words I am going to find the sequence. I am going to find the dependency with my input data. Okay, then I am going to find the attention score. So for attention score, if here is not there, they are going to consider as a infinite, minus infinite. So based on that, if I am going to calculate the attention score for my SAT, so this is the percentage. This is the percentage we are going to get, in which you can see the SAT is 0. My 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 cat is 55. Then the word has the relation is 45. Okay. See what I am trying to say. The cat attention score is 55 to the. So this word has the attention score with this the 55. This word with this we have 45 for the SAT 0. So what we are going to do, query and key. Fine. Now we will take this value. From this we are going to get the weighted sum for my masked self attention. Now using this score, we are going to do the mapping between the encoder and the decoder. So in the encoder and decoder part, we will use the whole sentence and its own word and its own token. So we are going to use the whole sentence, whole data, this whole data and its own word we are going to use. What is the intuition we are going to do? What is the intuition is happening here in the self attention? How do I relate to other words in my word sentence? So what is the meaning of self attention? How do I relate my word with the other words in my own sentence? So I am going to form the relation the with all other words. So that is called as a self attention. What is by masked self attention? How do I relate to each words I have to generate? So now I have the cat sat as the test. Now I want to predict this. Now what it will do, this guy going to do relation with all word to generate this mask, this one with the trained one. What is the encoder and decoder attention will do? Which part of the input sequence should focus on? So to generate this, so which part I have to focus here? Which part I have to focus here? Based on focusing, you are going to get the output. We are going to get the output. We are going to get the output. So that is the part is doing by the encoder and decoder attention. Okay. And finally, based on the important generated word, we are going to find the probability for the each word using the softmax. Based on the word, we are going to say the probability for getting the word. The next word is mat. So this is the way our transformer will work. Now we will see how our transformer is worked on the my ChatGPT. There are here typical examples I have given. One is writing the professional email. So you want to write the professional email. For that, how you can use the ChatGPT. Summarizing the document. You have uploaded some document. How you will summarize. Not only that task, we can use for generating the meeting minutes or translating the text, generating the code, explaining the technical content. But here I have given the only two exercise. One is called as a writing the professional exam, professional email. So for professional email, I will open my chat GPT. I'm going to put my query. So write the professional email. So first step, I'm going to do this one. So this is my input for my GPT. So what is my GPT will do? After taking my query, first step it will make it as a token. Then it will do embedding vector. Then it will do positioning. Followed by that, it will do self-attention mechanism. The next one, decoder part, what we are going to do? In the decoder part, now we are asking generator. So now what it will do? It will map this data with my existing data, and then it will generate. Now you can see how the generation is happened. So this is the way we got the output, the generated output for my given query, my given data. And we have reviewed. The second step, we can see the review. What is the output we got? I would like to request 1 day of leave on date as I need to attend my family function I have written. Okay. I have planned my work to minimize any disturbance, and I will ensure that any pending task. So for the given one, I got this the output, but I want to make this letter say in the form of formal one. So now I have to change my prompt, my query for my GPT. If I change, you can see the structure. You can able to see the structure, the request letter in the, here is the more formal version. The formal version is coming. More formal version is coming. The formal version, you can see the difference. Instead of writing sincerely, is written faithfully. Okay, faithfully. And another one, you want to keep the email under 50 words. See, now in short form. So what I am trying to say, what is the ChatGPT is doing? It's inside the ChatGPT we have the transformer. Transformer will take our input and analyze, and then analyze, followed by analysis, it will generate the data. So that is the thing is happening. What is the generative AI here? What is the learning outcome we have to do? Understand how the prompt working, change the output. See how the prompt this. So whatever I am going to give the input, for the each input, we are going to get the different output based on my encoder and decoder is behaving on my given data. Is it clear? So you have to understand how the prompts are changing and how the learnings are happen while refining the AI generated content. So these are the two things you have to note of this. Okay, note. Okay, in ChatGPT. Okay, in the transformer, what it will do? Token followed by token embedding, followed by embedding, we are going to use the positioning, followed by positioning, we are doing encoding and decoding. Okay, encoding and decoding and output. So that flow is given here. For my word generation. Similarly, for summarizing document is there. Okay, so this is one of the example for the GPT, and the next one for generating of the code. For generating of the image, we are going to use the model generator advisory neural network. Okay, the generative advisory neural network is the reason model. But in the older days, what we did for generating, we have used the like this specific parameter. For example, generating the model or generating the images, In older days, in computer network, sorry, in the computer graphics, we will feed like this. We will feed the like this input. For that input, we will get the raw output. How you will say this raw output is correct or wrong? We will do inference with the visualization system. With the visualization system, we have to do. We have to do the inference with the visualization system. We have to do. Okay. So basically, for generating the model, what we are going to do? Okay, many of our model will work the similar like this structure. What it will do? It will generate based on the condition whatever we specified, and we are going to evaluate with the inference. So the same generation and inference is played the major role in our generative in the GAN model. The GAN model. What is the GAN model will do? What is the GAN model will try to do? It will try to learn my existing data, okay, for generating the new one. How will learn? Based on the prior knowledge. Prior knowledge is called as a prior probability of my data. Prior probability of the data. So based on the prior probability, we are going to generate the new data from the existing one. New data from the existing one. Okay, so here some of the example for data generation on the real world. So this is your painted image, or you are going to generate the stroke paint on the on that. So like this you can generate. Okay, similarly, if you are going to give the input in the form of words like this, you can generate the images. You can generate the images. How these generations are happened? Through the probability. How that models are developed, that is given here, that is shown here, okay, that is shown here. So this is the in the generated GAN model. We have there are two things. One is discriminator, another one is generator. So what we have to do, first we will take our original image and we are going to feed it into the discriminator function. We are going to feed it to the discriminator function. Discriminator try to discriminate. Okay, does try to discriminate. At the same time, what we are the GERN has the another model generator. The generator will try to generate the new data from my original data using that probability. Using that probability that generated data and original data, both we are going to feed it to the discriminator function. If the discriminator function it can't discriminate between these two, then loss is more. Then what we are going to do, it's able to discriminate easily, then the loss is more. Then what we have to do, we have to go and update the loss. Based on updating the loss, we are going to update the weight for generation. Then we are going to generate the new way, and then we are going to feed it into the 1 second to the discriminator. So this is the way will work. So propagate the error to update the weights, because my discriminator can't able to discriminate. Is it clear? Fine. So that's the way we have to do. Fine. For this generator, I have one example in my Colab. Okay. See, I am going to do image generation using a custom GAN model. Custom GAN model. Okay. Run focus cell. Change running time to TPU. Save. Okay. Now what I am going to do, I am going to generate the data using a custom GAN model. So I am going to use the custom GAN model for generation. So in this code, I have given here I need package are NumPy, then matplot for show the output, tensor for writing the code, my generated advisor code. For that I need the keras. So within the keras, I am within the TensorFlow, I am going to use the keras Keras is the one of the file, one of the module. Within that, we need from that we need only layers and models. So that we are going to import. So here the TensorFlow version 2.0 already I have. Okay, so I followed by that. I am going to check whether my tensor is there. And next, what I am going to do, I am going to take the data. I am going to date the data from the MNIST data set. This data set already present inside the my Color, okay, or in my Python also is there in the package. So that's I have loaded here. So in the Keras data set, so in this package itself, we had this data set. So directly I have feeded here. That I am going to separate as a training model, training and testing model. So the training one I am going to written here, and I am showing this line is showing me my data in the form of 8 top 10. So that is shown here. And next, I am building the GAN. So for that model, I am going to build the GAN. So this is my GAN generator code. And this is the discriminator code. So here the parameter, what are the things we are going to use. Then here I am compiling and train my GAN. Here how many epochs I have used. I have used 5 epochs. Let's see how much time is taking. Okay, its time is running. So it's now I am training my input. Okay, my input. Training means I am generating my new data. Okay, so here I made the display the output if my epoch number 5 mod 5, you will get 1. Okay, so if it is 0 or if epoch is 1, you have to show the output. So that's the thing I have written. So there are 5 epochs I am written. If my epoch is 1, I have to show the output. It's taking time. Okay, and finally I am going to show the how many images are generated, and how my discriminator is able to discriminate. See, its epoch is running. After first epoch, I am able to get this. New data is generated. Okay, like this it will run. I don't want to waste my time because time is short. Okay, and that is my final one. So what we have learned, I will show this output at the end also, if it is ran. So what we have basically learned in this session, we have learned what is AI, what is ML, what is deep, what is generative. The difference among these 4, followed by that we have learned how generative AIs are created. For generating AI created, there are 4 architectures are playing. One is transformer, another one is called as a diffusion, next one is called as a GAN model, fourth one is called as a VAE. Okay, but among that I have clearly explained transformer. In the transformer architecture overview I have given, followed by that in the transformer architecture, who is playing the major role? Self-attention mechanism is playing the major role. That I have explained. Followed by that, we hear the tokenization and the embedding also is playing the major role. So those things I have explained inside the transformer. And next, I have given what is GAN. what is GAN, and I have shown the output for the GAN image generation. So that is the thing I have done in this session. Okay, thank you. I'll end my session with the code. The best way to predict the feature is to invent the new one. So we have to keep on invent new one. So that means you have to learn some new model. Okay, so such a way that you can be with the recent trend, you can have the knowledge on the recent trend. Without recent trend, it's very difficult for us to survey in the world. Okay, so please try to learn new concept. Is it clear? So that's the reason our FTP organizer taken the new technology as the topic to share the knowledge with the all the peoples on the world. Okay, thank you. If you may have any question, you can ask. In meanwhile, my screen is shared. It's running. So far, 3 epochs is over. The remaining 2 epochs will work. So here it's showing the loss happen, how much between the discriminator and generator. If you may have any question, in meanwhile, you can ask.
Thank you, Rajkumar sir, for your valuable question. So I would like to request to all the participants, I already unmute you. Okay, if you want to ask any questions, you can ask you. Just unmute yourself and ask the questions. Shweta Patil, madam. You raise the hand, Shweta Patil. Just unmute yourself.
You can see after 5th epoch, what is my output. So I have to do more epoch, then only I can able to generate the data. It's similar like my original data. See, like this, if I want to generate, still I have to increase the epoch. So that's the reason in my code I have mentioned, change the epoch till 30. So change and check it in your machine. Okay. So now final output is easily discriminate main function. See, it says this is fake. These are a fake. This is real. Is it clear? So if it may increase the epoch, it will give the better output. This is the way. This is the same model we have used in the this type of OpenAI model. Okay. So this is the thing I want to show with you.
You can see the today's session's feedback link and quiz link in chat. I'm requesting all the participants, so please fill it. Also, if you have any doubt, you can unmute yourself and ask the questions to the sir. Otherwise, you can also provide your queries and questions in chat also. Sir, another 5 to 6 minutes. Okay.
Yes, sir. Yes, sir. Sure.
So I'm requesting all the participants. If you still have any query, sir is available with us. You can unmute yourself and ask. Otherwise, you can also pass your queries in chat also.
Okay.
Also fill the today's session feedback as well as quiz.
Okay, this is my website. If you want, you can ping me. In my website, I have given all my contact details. Even in my first slide also there. See, this is my website. This is my website. You can go to my website. All my contact detail, even mobile number, my mail IDs are there. In future, if you want to contact with me, you can contact. Okay. So that's the thing I want to say here. Yes, sir.
Hello, sir. First of all, it
Yes,
was
sir.
a very nice session, sir. Thank you very much. Sir, I have one question like, which is the popular GAN variant which can be used, sir, right now?
GAN variant.
Where-
Sir, based on your requirement, you have to decide. Okay, I cannot say this is the best GAN for your model. Okay,
Uh, uh,
you
no, sir.
we cannot. Yes, sir.
I am hearing about that style GAN.
Yes,
That's
sir.
why.
Yes, sir. The style and all the BTech students are for a project they are using.
Okay.
Okay, so really you have to test with your own data such a way that only you can know how your model is learned. Okay,
Okay.
so you
Uh,
just I am saying, sorry, you can use style GAN. I
uh,
cannot assure your style GAN will give for your data will provide better output or your expected output. So that's the reason I gave the answer as it's open to you. You have to test with the many model, or what do you have to do? You are going for developing some model, some GAN for your data. Check your
mm,
similar kind of data. Already some researches are worked.
okay.
Okay, and find who is the best they have mentioned. That model you have to try to train on in your work. Is it clear? That is the way only you have to do. And in meanwhile, when you are going to implement that, you may feel why in this model I can't change the probability function, or I can change the weight function, or I can change the error function. After
Mm,
changing that some modification, you may get some point not improvement from the previous one. That is the way only we can do, sir. Is it clear?
okay.
So we
Uh,
okay, sir. Yeah.
so means there is no trial and means there is uh, correct method means based upon the model we have to try and then only we have to work.
Yes, sir. Yes, sir. If you want for correct model, I already said, go for research article, people whoever work, and find and implement that model for your work first. That
Yes,
is the
yes,
thing
yes.
I will say.
Thank you,
If
sir.
you
Thank you.
want to develop your own model, try
Mm,
to find what are the bugs are there in that model and try to improve that using some of the hyperparameters. That's we may call it as a fine tuning of the model. Okay, sir.
fine. Okay, sir.
Yes, sir. Yes, sir. Any
Thanks.
other?
Thank you, sir.
Thank you. Thank you.
Thank you, sir. Now, I
Thank
would
you,
like to
sir.
request all the participants just on your videos. That's why we will take one group photo. Okay, thank you. Thank you very much. Okay, thank you. Thank you very much. So, on behalf of DYPCET College of Engineering and Technology, Department of Computer Science and Engineering, I extend my heartfelt thanks to Dr. Rajkumar sir, who gave us the valuable insights, practical examples, and deep knowledge of generative AI. So, I am very much thankful, sir. This session is very informative, and we sincerely appreciate the time and efforts you have taken to share your expertise with our participants. Unless you are having the sticky schedule, you have to find out the times. So once again, thank you very much, sir. We wish you continued success in all your academic research as well as professional endeavors also, sir. Thank you, sir.
Thank you, sir. Thank you.
So here today we are conclude our morning session. So sharp 1:45, I'm requesting all the participants to join. Okay, the link will be shared in WhatsApp group. Okay, thank you. Thank you very much. You can leave now.
हो आहे की. हा. हा. किती पर्सेंट आहे सीईटीला? 45, 85. आणि कॅटेगरी कोणती येते? हा हा.